This video is about Sankey diagrams. In physics, Sankey diagrams are used to visually represent energy flow during a process or in a device. Here is an example of a Sankey diagram that shows energy flow in a car engine. Let's see a few general points about Sankey diagrams. On these diagrams, energy sources and energy losses are represented by arrows. The diagrams are drawn to scale, which means that the width of each arrow is proportional to the amount of energy it represents. Energy flow is drawn from left to right, and energy loss is represented by arrows that move towards the bottom or the top of the diagram. You can easily observe these four features on our example diagram. Let's see what else can be deduced. The total energy, or 100%, is represented by 5 larger squares. This means that each larger square stands for 20%. Since the width of each large square is equal to 5 smaller squares, a small square stands for 4%. Let's follow the energy flow on this diagram. The first energy loss is due to heat loss in the engine. The width of this arrow is 2 larger squares, which means that 40% of the energy is lost as heat in the engine. The second cause of energy loss is sound energy produced by the engine. This is represented by a width of 3 smaller squares, which stands for 12%. Heat energy lost due to friction is 28%, so only about 20% of the total energy produced in the engine is converted into the kinetic energy of the car. In this example, we work with percentages, but you might also see Sankey diagrams where energy values are given in joules. A final point is that Sankey diagrams can also be used to show power transfer, and in this case, power values would be given in watts. This wraps up our discussion of Sankey diagrams. In the next video, we'll start learning about thermal power stations, and we'll also look at a specific type of power station powered by fossil fuels.